4.2, constructing a second solution from a known solution. This is a pretty cool section, but the only catch about it is that you really do got to know one solution first in order to get the second solution. So sometimes there are problems that there may be some difficulty finding a solution. You may get one solution, and finding that second solution may be very difficult. You can use this formula. That's all this section is, just a formula. You can use this formula to solve for a second solution to a differential equation. The neat thing about this is that this method works, but it only works for second order differential equations. So if it's the third order or anything different than that, then you can't use this method, which is fine because most of life hovers in the second order realm anyway. Okay. I don't know if I told you, but I took a class in graduate school. It was partial differential equations, and for that whole semester, we only dealt with one equation. And a lot of us still didn't get it after that semester either. that's how intense that was. So, and it was a second order partial differential equation, just one equation. I had a friend of mine, he has a doctorate in physics, and he has like 3 masters, and one in chemistry, one in physics, one in something else, material science. So now he's working on a master's in mathematics. Don't ask me why. And so he's taking partial differential equations, and he asked me about that particular problem. I said, man, you better leave me alone. That was 25 years ago. We had a really lame instructor up there at Pittsburgh, and I said, man, hey, I said, look, I made it through it. I don't know how, but I took that. I hadn't seen that stuff ever since. So most of my work has been actually in differential equations. So anyway, ordinary differential equations. Constructing a second solution from a known solution. Here's the formula. Here, in this section, he deals with 2 methods of solving. One is reduction of order. I will not cover. I have covered that in the past. I think it's easier just to use this formula to get the second solution. For the reduction of order, it's still the same concept that you have to know one solution in order to find the second solution. And so it's 2 methods to do the same thing here. Either reduction of order, which is pretty neat because you reduce the differential equation, simplify, and typically you can use separation of variables or homogeneous equations going back to chapter 1, chapter 2 actually, to solve. Well, forget about all that. Just use this formula and be done with it. Okay. So the formula is based on how the second order differential equation is written out. Here, write the second order differential equation in the form y double prime plus p of x, some function of x, times y prime plus some function of x again, q of x, times y equal to 0. Now here's what that means. You know, if you take English literature and you read a poem and you have no idea what they're talking about, you know, so then it takes like maybe your instructor or you go read up somewhere and you read this line, and okay, this line says, thou sittest, you know, under the pomegranate tree, and I smelt, you know, your fragrance, you know, from the flowers that budded. And you say, okay. But then the translation is something really naughty, right? You know, it's like, I didn't see that, right? Well, so it's something in this formula, well, nothing naughty, but there's something in this equation, and here's what it's saying. What it's saying is that you may have some problems where, see that y double prime, there may be something multiplied to it. If it is, divided through the equation. That's all they're saying. so that then you can identify the P of X. And then, not now, but later on, you can also identify Q of X. Bless you. We don't need, at this time, for this formula, Q of X, but we do need P of X, because P of X goes up into, is the second solution is equal to the first solution times the integral of e to the negative integral of P of X dx. Kind of reminds you of that integrating factor, mu equal to the integral, e to the integral of P of X dx. So you got that, but it's a negative there divided by the second solution, the first solution squared dx. Right? This is probably good for you that this is one of the formulas that I don't prove. The rest of them hereafter I will prove in class. So if you ask me, I can prove it, but we just use it. Okay. Use that formula then to solve for the second solution. So let's take this problem here. So I'm given the first solution to be this, and so we use that formula. Well, the formula says that the second solution is equal to the first solution times the integral of e to the negative integral of P of X dx all over the first solution to be squared dx. Well, look at the equation. Is y double prime, its coefficient is 1, so nothing that I have to divide through by. So I can identify P of X. P of X is at -4. So the second solution is the first solution, which is e to the 2x times the integral of e to the negative integral of -4 dx all over the first solution, e to the 2x, all to be squared dx. So we simplify that. This is e to the 2x times the integral. Here, this is e to the 4x. This is divided by e to the 4x dx. So the second solution is equal to e to the 2x times the integral dx. Well, that gives us x times e to the 2x plus some constant. Right? Let here the constant equal to 0. Let c equal to 0. Let's do a little operation. Where's my operation? Just a little bit. Let c equal to 0. So y sub 2 is equal to x times e to the 2x. Now the question is, why was I able to let c equal to 0? Because here I'm not writing the general solution. I'm just writing that, trying to get that second solution. You remember when I apply the superposition principle, y then equals to c sub 1 times the first solution plus c sub 2 times the second solution. Those constants will help us, if I'm given an initial condition, to find all constants, for that particular differential equation. So I'm not throwing the constant away. I'm just identifying, just trying to weed through, pinpoint. That's the second solution right there. Right? Second solution is this guy, x times e to the 2x. Any questions? I'm almost done. Let's go back and look at the problem. This is equal to 0. So these two solutions would be complementary solutions to the homogeneous differential equation, right? I just want to find y sub 2. This is the second solution. Yes, sir. Yep. Anytime the differential equation is equal to 0, it's always the homogeneous differential equation, and the solutions then would be the complementary solution and not a particular solution. Okay? Let's look at number 3. So here, do you see that P of x is equal to, anybody know? P of x is equal to 0. Yes, sir. Exactly. There is no y prime, right? So P of x is equal to 0. Very good. So y sub 2 is equal to the first solution, which is cosine 4x times the integral of e to the negative integral of 0 dx. That's divided by cosine 4x to be squared. This is dx. So this is equal to cosine 4x here times e to the 0 is just 1. So 1 over cosine is secant. So this is just secant squared x dx. Oh, it's a 4x, sorry. I'm smelling my wife's Sloppy Joe sandwich up in my office. And I tend to lose stuff. She made Sloppy Joe. I was at a meeting last night, and I told the people at the meeting, I said, I'm going home, and hopefully my wife has something for us to eat. So when I got home, I smelled Sloppy Joe. I said, praise the Lord for a good wife. Yes. Man, it was good stuff. Good stuff. Big Sloppy Joe sandwich with a banana and a glass of water. Yes. Yes. Anyway, what's the integral of secant squared x? The derivative of something gives you secant square, so the integral of secant square is that antiderivative. So what is that? Yes, the derivative of tangent, right, is secant square. So here, y sub 2 is equal to cosine 4x times tangent 4x all over 4, right? Plus c, right? Isn't that a u du? You have to let u equal to that 4x. du is 4 dx, right? So I get 1/4 du equals to dx. Right? Is that all right? It's okay. So you simplify this. This is, well, tangent is sine divided by cosine, so this is just sine 4x all over 4 plus c. Here we take y sub 2 to equal sine 4x. Again, when I attribute a c sub 2 in front of that sine 4x, that's going to pick up for me that 1/4 down there. And then if you have a non-homogeneous differential equation, you can pick up the constant c. You understand that? That's how my granddaddy was back out working out in the field with him. He'd tell you to go do something. Huh? My brothers, they'd be like, what? You know? Then he'd get mad, you know. Well, so he's like, you know, maybe down this field, like maybe about a half an acre or so, you want to go down, make a sharp right, and then when you make that sharp right, you can look for whatever he's talking about. Maybe it's a bucket. He got a hammer and some nails in that bucket, you know. So, you know, I was the only little kid that he'd do something like that. And I'm already walking down there because I can read the old man, you know. He's fussing at everybody else, you know. What you mean you don't know what I'm talking about? But anyway, so Christian, you need to understand, okay, all right, all this stuff, this sine 4x divided by 4 plus c, that's all this stuff You don't need all that for the solution for y sub 2. The main contributor is that sine 4x. Right? Let me show you. See, the actual solution is this. Y sub c, because it is a homogeneous differential equation, y sub c is equal to c sub 1 times cosine 4x plus c sub 2 times sine 4x. That c sub 2 could be 1/4. Right? See that? So those constants, when you plug that in, this form here of the solution, this is the format that comes from the superposition principle, right? And so it takes into consideration all of these constants and coefficients. Say that again, I'm sorry. In using this formula to find the second solution. Yes, sir. The superposition principle puts the constants back in there. And so if I'm given initial conditions, here I will use the initial conditions to solve for c sub 1 and solve for c sub 2. So we're not throwing anything away. Right? I'm just weeding out through the mess, you know? I'm just getting what I need. Yes, sir. Yes, sir. That's all I need. I need the solution, the main contributor for that particular problem. So I think there was one more. Oh, this one right here. We'll do this one, and then we'll give the introduction to 4.3. This problem here has the implication that y double prime plus 1 over x times y prime is equal to 0. I have to do that so that I can relate this problem to y double prime plus p of x times y prime plus q of x times y is equal to 0. If there's anything associated to that y double prime, I have to divide it through. So now I can identify p of x, because p of x is 1 over x. If I didn't do that, I think that p of x is equal to 1. And you would be totally wrong. See that? And just one little thing like that, man, just mess up the whole problem. You know, can you give me partial credit? No. Okay. So y sub 1 is equal to the natural log of x. So then y sub 2 is equal to the natural log of x times the integral of e to the negative integral of p of x, which is 1 over x dx. This is all over the natural log of x, that first solution, to be squared, yes, dx. And so this is the natural log of x, yes, is equal to, this is e to the negative natural log of x. That's all over the natural log of x to be squared dx. So y sub 2 is the natural log of x. This is the integral. This e to the natural log of x is e to the natural log of x to the negative 1. Basically, that's just 1 over x. All over the natural log of x to be squared dx. You saw how we got 1 over x, right? Okay, so this is the natural log of x times the integral of 1 over x times the natural log of x to be squared dx. How do we integrate that? Have you seen that integral before? Not talking about the natural log of x in the front, it's just the coefficient, so it has no bearing on the integration. But the integral of 1 over x times the natural log of x to be squared. Have you seen that type of problem before? Christian, did you have my calculus too? Okay, okay. So probably why you hadn't seen it before. That's one of my favorite type integrals in calculus too. Chapter 8. Tress. Deep voice. Because that's something out of chapter 9. You gotta, you respond, you talk to a dude, he got a deep voice, you gotta make your voice deep too. Man, some salesperson, something called my house. Can I speak to Veronica Williams? Hey, you want to talk to my wife? You got to talk to me. Who is this? This is the bank. Huh? What y'all want? This is something about a bill. Baby, come get the phone. My voice gets hot here, Dear, come get the phone. It's for you. I don't want to deal with no kind of bill, man. Anyway, how do we solve this? Anybody have any idea? I mean, you're thinking UDU, you're thinking integration by parts. Integration by parts. I mean, you could do it like that, but it's not that difficult. You can do it a whole lot easier. Yes, sir. So what would u equal? Yes, sir. Let u equal the natural log of x because the derivative of the natural log of x is 1 over x. It picks up the 1 over x dx. We're halfway home. So let u equal the natural log of x. This implies that du is that 1 over x dx. He took my sins and put them in a bag. And then he threw the bag away. Okay. So here, y sub 2 is the natural log of x times the integral. This is 1 over, now this natural log of x here, that's u, so this is u squared. And then that du picks up the 1 over x dx. Right? So the du does everything else for us. So this is the natural log of x times the integral of u to the negative 2 du. So this is the natural log of x times u to the negative 1 divided by negative 1. So we'll put that out in the front, if you will. So this is negative 1 over u times that natural log of x plus some constant. And u is the natural log of x. So y sub 2 is negative 1 over the natural log of x times the natural log of x plus c, fuzzy. So here I get negative 1 plus c. We take y sub 2 to equal to what? 1. Because this negative picks up the c sub 1 or the c sub 2. What's the general solution for this particular differential equation? Y sub c is equal to c sub 1 times 1 plus c sub 2 times the natural log of x. In other words, this is just c sub 1 plus c sub 2 times the natural log of x. So basically, 1 is a solution, and the natural log of x is a solution. If you had chosen negative 1 for a solution, that'll still be correct. Okay. Think about it. Go back to the problem. If 1 is a solution, that means that 1 is equal to y, so y prime is 0, right? Take the derivative of 1, you get 0. Take the derivative of y double prime, you still get 0. So basically, 0 plus 0 equals 0. Nothing from nothing equals nothing. You gotta have, okay. If you let if y is equal to the natural log of x, then just check to verify the solutions, just quickly. Y sub 1 is equal to 1. Y sub 2 is equal to natural log of x. Y sub 1 equals 1. This implies that y prime equals to y double prime, that equals to 0. So you look at the problem, that's x times 0 plus y prime, which is 0. That's equal to 0. If you let y sub 2 equal the natural log of x, its derivative, y prime, is 1 over x. Right? That's x to the negative 1. And then y double prime is negative 1 over x squared. So you plug that in. This is x times y double prime. Is it plus x or plus y prime? So this is x times y double prime, negative 1 over x squared, plus y prime, that's 1 over x. This is negative 1 over x plus 1 over x, 0. Right? Any questions there? Question? Let me give an introduction to 4.3. It won't take long. It's very short.